Hi everyone. In this video, I want to focus on a few projects out there that help you extract embeddings in a very performant manner without requiring GPUs. The first project I'm going to talk about is rust-bert. This is a Hugging Face transformers library, but written in Rust. And while it supports many NLP tasks, I'm only talking about sentence embeddings. The reason sentence embeddings have become so popular these days is one, they're used in a lot of the retrieval augmented generation pipelines, especially when you need to extract embeddings from your documents, or chunks that are extracted from your documents need to be converted to vector embeddings. That's when you go and use an embedding model. Sentence transformers is a very popular one, but there are many others out there. The approach that rust-bert has taken is it's converted many tasks that you would use Hugging Face libraries for into Rust. And there are some standard, or you would say smart defaults that this library comes with. Now, I realized when I started to, find and explore these options, it was important for me to use it without having to learn Rust. And that was a barrier for me because I am trying to learn Rust, but I'm not proficient at it as much as they say Python. But then I realized that maybe I could create a solution that would be useful for me and others. So I took the rust-bert library, teamed up with a Rust developer, and we put together this Docker image. So when I sort of commissioned the developer to create this project, the idea was, can we take rust-bert and wrap it into a web service? And that's what you see here. So you could use this for free. It's a Docker image. And when the container runs, it basically creates an endpoint that can be called with the various features that are available. I didn't extract, or I didn't create all the features from the original rust-bert library. But using rust-bert, I've exposed API endpoints that allow you to do zero-shot classification, sentiment classifier, keyword extraction, named entity recognition, part of speech tagging, and sentence embeddings. I originally wanted to create a service only for sentence embeddings, but I thought maybe these are other popular tasks that folks might be interested in. So let's just talk about what these are very quickly. Zero-shot classification is the ability to ask a model what a piece of text belongs to in terms of its class label. So the idea is you give a piece of text and potential class labels and get back a response that identifies the probability with which each class can be ascribed to that piece of text. A sentiment classifier is obviously a classifier that identifies positive, negative, or neutral sentiment on a piece of text. A keyword extraction feature allows you to extract very important keywords from your text data. A named entity recognition module would allow you to extract entities such as a person name, organization name, location, and a few others. A part of speech tagging feature allows you to tag a piece of text with its parts of speech, like a noun, a verb, adjective, prepositions, and so on. And a sentence embedding, obviously, the main focus these days, allows you to take a piece of text and convert it to a numerical representation, which is a vector of numbers, using different models. Now, if you wanted to use this Docker image, it's very simple. I've also put together a tutorial on how you can use it, and I've also shared, sample inputs that you could use. Like I was suggesting earlier for zero-shot classification, these are two sentences that you'd like to classify. And for each sentence, you'd like to know which is the most likely class label. And here are the candidate labels that you supply. So the idea is that you could actually, instead of sending one sentence or one paragraph at a time, you could actually batch it together in an array of multiple inputs. And the latencies are, very, very promising. And, I've also shared the kind of response you can receive from the API endpoints. And I've done this for all the features that are available. So have a look. And if you find it useful, come back, subscribe to my channel, and keep listening to a few more videos. The second and few other examples I wanted to showcase was around a lot of work that's happening in the Rust world at the intersection of Rust and machine learning. So Candle is a library that was created by Hugging Face, and it's written in Rust, and it focuses on performance. And you can see some examples. I wasn't able to load the example on the Hugging Face website, but many of these examples actually load up in the web browser. You could run a small version of Whisper, Llama 2, T5, YOLO, which is a machine vision model, segment anything again for machine vision. And being able to run this in the website in the web browser is because Rust also compiles to WASM, which is WebAssembly, which is a form of code that can run in your browser. I'll do another video and deep dive into WebAssembly and what's happening with ML and WebAssembly. There's not a lot happening as much as at least Python, but whatever is being done in that field is very fascinating at this point. So if you're a Rust developer, or if you're interested in learning Rust, you've had a lot of experience in other programming languages, check out some of these frameworks. They're actually growing, and there's a lot of promise here. I think the entry barrier is a bit steeper, if I may say so myself. At least for me, it has been, coming from a Python programming background. But I think with time and with the assistance of smart copilots like GPT-4, I'm able to make some headway with learning Rust. The other sort of libraries out there that are showing promise for fast inference or extracting embeddings in a performant manner on CPUs is Fast Embed. It's from the people who created Quadrant or Quadrant vector database, and some of the items that I see in the GitHub, I haven't tested it yet. It's something on my radar, but some of what I see here is very similar to what I'm seeing in other projects. But it seems like these are good contenders. If you're already using, say, Quadrant, there's deep coupling with that particular solution if you use this library. Neural Magic has built some very important libraries in this space too. Deep Sparse allows you to again do vector embeddings at scale very quickly on CPUs. There are Hugging Face models with some of the very popular sentence embeddings converted to a sparse format that can be then used with Deep Sparse library. So there's a lot of I think work happening in this area. I've recently tested Llama CPP, where you can download the GGUF format that is posted almost very regularly by the bloke on Hugging Face. And I've tested this on my CPU. I don't have GPUs locally. And when I tested them, there were some challenges, but for the most part, I could run a Llama 2 7 billion, a Llama 2 13 billion model. The results were acceptable in some cases, but in some cases, the results were just not acceptable at all. But at least for embeddings, what I'm seeing is very performant libraries out there, where you could inference 100 plus sentences in a second or more, actually. And being able to do that on CPUs really saves cost of GPUs, which probably will keep seeing some supply shortages and spike in pricing. But having a solution for CPUs is very important. Well, that's about it. I have shared some of the options out there. If you are looking for fast inference, you can try out this Docker image. Right, it's very simple to use. Some of the folks who I've heard feedback from tell me that they need a decently performant system to run this entire image. The image itself is very large, probably more than 8 gigabytes, because it packs in the Torch runtime and a lot of the other dependencies. And in my recent research, I found that I could convert some of the work done on rust-bert into Candle. That's on my radar. I might release a Docker image for the general consumption by refactoring some of this work into Candle, but that may not happen anytime soon. So if you have a performant system, try this out. You get a lot of the NLP features, and you should be able to run this at scale. You can sort of run as many containers as you want, and you could really improve the throughput of your tasks, especially the sentence embeddings. Thanks for listening. Again, if you found value today, please subscribe. It's very encouraging to see new subscribers, and please do leave comments about what you'd like to see in the near future, what you thought about this video, and any feedback for improvements. Thank you.